So dear students, today's topic is RC circuit. We will solve a basic problem on RC circuit. This is what we are going to talk about, a basic RC circuit, resistive and capacitive circuit, right? This is what we are going to talk about today. So this problem is taken from Boyle's book, and the name of the book is Introductory Circuit Analysis. I have taken this from the 10th edition, written by Boylston, and this problem is given on page number 397. Okay, so I have written down the first two parts of this question. So before getting into the main question, I would like to tell you that RC circuit, this is what a basic RC circuit looks like. Let's say we have a source, voltage source here, a resistor, then let's say we have a capacitor somewhere over here. Okay, so let's say if we have a 10 volt source and let's say 100 kilo ohms resistor, and there is 0.05 microfarad capacitor, what will happen is current will start flowing in this closed circuit, and as we have a voltage source connected to it, the capacitor will be charging. Like when the current starts flowing through the circuit, the capacitor starts charging. So once the capacitor is fully charged, at that point of time, the voltage across this capacitor should be equal to the voltage source that is connected to it. So what I am trying to tell is, if we have a 10 volt source, at certain point of time we will be having Vc is equal to 10 volts across this capacitor after some point of time when this capacitor is fully charged, right? So this is what you need to remember. This is, you can say, it's in charging state. That's called charging state. Why is that? Because the capacitor is charging. So now let's look at the discharging phase. If we have a circuit like this, here this capacitor of 0.05 microfarad is connected to a 200k resistor, right? So in that case, when the current starts flowing in this circuit, is there any voltage source connected to it? There is no voltage source connected to this one, so the capacitor will start discharging. So it will dissipate energy, and after some point of time, all the energy stored in the capacitor will be discharged through this path, right? So this is what you need to remember. This is a very basic thing you need to remember. And another thing I forgot to mention, the formulas and the graphs. The formula for the charging state, let me write down the charging states figure once again, right? It's the figure of charging state. So if we want to find out the voltage across this Vc, what will happen? I told you that it will start charging the capacitor and it will show a transient behavior. Transient. You need to remember this one. This capacitor, this RC circuit, will show or illustrate a transient behavior. What does that mean? Yes, of course the capacitor will get charged, but not like It will not happen overnight. It will take some time to charge the capacitor. Let's say it will not start it will start charging from, let's say, t is equal to 0, but t is equal to after some seconds or milliseconds or nanoseconds it will charge the full capacitor. It will not charge the capacitor at once, right? What I'm trying to tell is, you need to remember one thing, that is the capacitor will gets charged, it will be charged after, when it will be fully charged after 5 time constant. 5 time constant is denoted with tau, 5 tau. So after 5 tau the capacitor will be fully charged and the graph will look like this. I will talk about the graph as well. Okay? This is the charging phase. So you might be asking, what is this? So in the x-axis we have time t, right? And in the y-axis we have this voltage, or you can say, as we have denoted this one with E, you can say E, or you can also write voltage, whatever you want to write. Okay, and as you can see in the graph itself, the voltage gets to the maximum point after 5 time constant or after 5 tau. So this thing you need to remember, 5 tau, and tau is nothing but RC. What is R? R is the value of the resistor, C is the value of the capacitor, right? This thing you need to remember. And if we are asked to find out the voltage across this capacitor, that can also be found using this formula. Vc equals E into 1 minus e to the power minus t over tau. Using this formula we can figure out the voltage across this capacitor. So if we are asked to find out the current across this capacitor in the charging state, that can also be found using this formula. IC is equal to E over R e to the power minus t by tau. Okay, IC is this current. Okay, current flowing through the capacitor is voltage divided by the resistor value e to the power minus t over tau. So this thing you need to remember. These are the formulas that will be used for solving this problem. Okay, and I'm not getting into the discharging part. Discharging part will be discussed in another part. Once we finish this one, we will talk about the discharging part as well. Okay, so now let's get into the main problem. So let's get into the question first. So the question tells us we are being asked to find the mathematical expression for the transient behavior of the voltage across this capacitor of figure 1 if the switch thrown into position 1 at t is equal to 0. So at time 0, this switch, it's a toggle switch, it's connected to 1. So what is the mathematical expression of the transient behavior of the voltage? So we are being asked to find out the voltage across this capacitor, right? So the circuit will look like this. We have 10 volts here, E is equal to 10 volts, this value is 100k, this value of C is 0.05 microfarad. C is equal to, right? Okay, so now we need to find out the value of VC, right? This is what we need to find out, and VC can be calculated using this formula, E into 1 minus e to the power minus t over tau. So we know this value of E, it's 10 volts, and is there any other value we need to know? Yes, there is another value that is unknown, that is tau, right? That is tau. We don't know that value. So what should be the value of tau? Tau is R into C. R is 100K, right? 100 into 10 cube multiplied by C value is 0.05 into 10 to the power minus 6. That gives us a value of 5 millisecond, right? Tau gives us a value of 5 milliseconds. In other words, you can write this as 5 into 10 to the power minus 3 seconds as well. Okay, so plugging in all the values, if we plug in 10 into 1 minus e to the power, so what about these values? Do we know the value of t? We need to keep this as it is, so minus t over tau is 5 into 10 to the power minus 3, right? So this is actually the expression for this VC, right? So what about IC? So in part B, we are being asked to repeat the part for IC. IC is nothing but the current in the charging phase that is flowing through the capacitor. So IC is equal to, so this is nothing but a series circuit. For series circuit, we know that I is equal to V over R. One additional term will be added, and that is, so V is nothing but the voltage across the capacitor, so we need to write down, V is the voltage across the source voltage. So IC is equal to V over R e to the power minus t over tau. So E holds a value of 10 volts, R has a value of 100K, 100 into 10 cube, and this thing should be multiplied with e to the power minus t over 5 into 10 to the power minus 3. So these are my final answers for the charging phase. So now in a while we will be talking about the discharging phase. We will see the questions and we will try to solve the problem as well. Ready to let go. You decide if you're ever gonna let me know. Yeah.